Hello everyone and welcome to Jigyasa's webinar From Models to Monitoring AI's Role in Credit Risk. Let us begin by talking about sampling and data challenges. An organization typically has information of performance only on the loans it has approved and funded. So because of that, training models only on the approved application will create a certain selection bias because you are not able to observe the performance of the people you have excluded from the pool, and this would mean that the model cannot be a, extrapolated and generalized to diverse applicants not included in the funded pool. Now, there are techniques in machine learning and data science related to really reject inferencing, which try to infer the performance of the non-funded group. There are some statistical techniques, machine learning techniques, and a very popular method is also to go to the bureau and augment the data with bureau performance. So the people who were not funded, we would go to the bureau and see if we can find comparable performance on loans and for a comparable time period. So these are the approaches we take. Now with AI, we can take another approach, that is of synthetic data generation. So using synthetic data generation techniques, we can simulate the performance of the non-funded group and use it for our modeling. We could also limit the amount of expensive bureau data we need for reject inferencing and use a small amount of bureau data and then use synthetic data techniques to kind of increase the volume of that bureau data and use it in our modeling. All of these techniques in machine learning and synthetic data generation allows an organization to be more compliant because they can ensure their scorecards are built on representative samples and does not propagate the funding biases they might have to start off with. Let me now talk a little bit about a related issue of data sparsity. So data is sparse if an organization is new or getting into a new segment, or and it does not have a lot of borrower information for that segment, or if it's a new organization it does not have a lot of data per se, and this inhibits a model from building, predicting accurately and identifying the correct patterns because it doesn't have enough sample to work with. And a related problem which we often see is that organizations are too conservative in the way they give loans. Because of that, they have limited defaults and so are not able to make models that can predict default. Now, uh, in all these situations, synthetic data augmentation can help an organization. Using AI generated synthetic data, the sparse sample can be expanded, or the few defaults that are there can be blown up to multiple defaults, and that allows more robust statistical analysis to take place. Now, in doing this, one has to be anchored to the real world, and and one needs to regularly update their sample. So you start with a lot of synthetic data and you gradually phase it out by augmenting it with real data as it comes through. So the proportion of your sample which is synthetic uh, can be slowly reduced, or at least as real data comes, it should be validated to make sure that the model is holding true. Let us now talk about how machine learning and AI can help with optimal segmentation. So the first thing we need to address here is why segmentation matters at all. So borrowers are typically very heterogeneous and diverse, and so they might have different drivers of risk, and their risk behavior might not be captured by an unsegmented scorecard, and that is why segmentation would be a very important exercise here. And then uh, there is the case of aligning with business goals. Different parts of the business might operate differently. You might have different products. You might measure default differently in different business groups. In some you might look at 90-day past due, in another you might look at 60-day past due for different reasons related to the specific properties and risks associated with the lending product. Uh, and there might be other business objectives and operational differences too. Because of that, it might be good to segment and build different scorecards there. And then there might be data constraints. A lot of times you might have groups which do not have, for example, certain types of data. Other groups might have, let's say, bureau data. Now, you might want to use the richer data where available, and for the groups which do not have the data available, you still want to be able to predict their risk profile. Because of that, that might be another reason for you to do the segmentation. We will not get into the technical details of segmentation using machine learning uh, today. We have a separate presentation on that, but I just briefly wanted to mention a couple of important things here. First is the difference between unsupervised and supervised clustering. Unsupervised clustering means there is no goal to that clustering exercise. It is just done to find the natural pockets into which the data breaks out. And there are several techniques to do that. Principal component analysis, canonical discriminant analysis, K-means clustering. The key thing is it's just looking for natural pockets within the data without a goal, opposed to supervised clustering, which is a little different, where you have a goal. It might be, for example, default, or could be anything else. And what you are doing is you are finding clusters in the data based on that goal. And a good segmentation strategy from a data science perspective uh, evaluates the sample both based on unsupervised clustering, because that tells you how the natural layout of the data is, but also looks at supervised clustering because that gives you information on, based on your goals, how the segments fall out. So let me talk now about combining the algorithmic segmentation we talked about just now with business insights and requirements. So the first step in this segmentation exercise almost always should be the algorithmic segmentation. And then we should then uh, look at business logic refinement. These might be business needs. There could be certain legal requirements which you have to follow, and certain things might not be allowed, so your segmentation needs to be adjusted based on that. And there might be operational needs, uh, because of the way the business operates, and you need to take all of this into account, work with the different business partners, and modify the algorithmic segmentation based on this. And then there comes the validation and adoption phase, where you ensure the final segments you obtain are statistically sound, they validate well on samples on which they will not derived, and they assure the, that the uh, that the different stakeholders are all on board with it, so that there will be adoption of this segmentation. Let us now talk about how AI techniques can improve the predictive power of a credit risk model. So we started by experimenting with models such as DeepSeek, uh, Llama 2, and several other lightweight large language models. And some of you might have seen or attended our webinars on this. Um and then we took those large language models and we generated vector embeddings from those large language models, uh, and uh, by feeding it a credit risk data set, one record at a time. And these then embeddings were used as predictors, along with traditional other predictors in machine learning techniques like XGBoost or logistic regression to generate credit risk scorecards and uh, predict performance. And in other cases, we took large language models and actually fine-tuned the final layer of that large language model, adapted it to the local data, and used it to predict credit risk. And in all these cases, what we found is that using large language models to essentially generate predictors for credit risk leads to significant improvement in model performance. So if you see here, um, this shows the AUC of a traditional model, which used just the standard credit variables you would use in a models. And then we used the traditional model plus the embeddings we extracted from a large language model. In this case, we did this both with Llama 2 and DeepSeek, and then using them together, the model performs a lot better. And then finally, if we are able to fine tune the credit risk model, or rather, we fine tune a large language model's last layer, and uh, then use it to predict the credit risk, which is called transfer learning, we essentially get even stronger results. The important thing to note here is all these were done uh, within our environment. So the large language models were actually downloaded within our servers, and the lightweight model we use for transfer learning was also downloaded within our servers. So uh, no data was exposed to the cloud. So the next thing I want to talk to you about uh, is Vision AI. And Vision AI is basically, these are not large language models. These are another class of AI models which work with pictures rather than with words and text. And again, we have had presentations on this in the past, but Vision AI can improve model performance in many ways. Again, the embeddings from Vision AI can help boost traditional machine learning models. uh, Vision models are very good at capturing intricate non-linear relationships, and because of that they do a very good job of extrapolating and figuring out what the nonlinear relationships are between two predictors, and helps the model's performance in a big way. And then there is this whole area of multimodal approach to combining image and textual data, which lead to even richer models. We have a presentation on that coming up in early December. Now, so using Vision AI on the same sample, we were able to improve our model performance even further. So I showed you the same chart, and this was done with the same data set. Now I've added another uh, graph here, another data point rather, for vision model. And as you see, when you started with the traditional model to the end where we are actually using vision models, uh, the performance has gone up quite a bit, and there is a lot of opportunity for us to improve the quality of our credit risk scorecards using large language models, vision AI, and get to uh, being a lot more efficient in managing our credit risk. Another area which can help uh, with model enhancement is the exciting and emerging world of synthetic data. So, you know, AI generated synthetic data allows us to model underrepresented sparse groups. We talked about that. So it allows us to create better segments within our sample. Now, once we do that, uh, we are then able to create more detailed and comprehensive models related to superior results. But it would be a fair question at this point for you to ask is, okay, this is synthetic data, how do I know that it will have the same quality of prediction as the real data? So we did some experiments on this, and again we have a separate presentation on that you can see on our YouTube channel. But uh, basically, if you look at this, we built with the model on the same credit card data we have been using throughout this exercise. We built a model with real data. We used a portion of the real data to build synthetic sample, and we built a model on this and synthetics sample as well. And then we had an holdout sample which was not used to build any of the models or the synthetic sample, and we looked at the performance of both the models there. And as you can see, the synthetic sample actually does slightly better. So this kind of should give you confidence that synthetic data can help with model enhancement. These tests need to be done to make sure you have generated the synthetic sample properly, but once you've done these tests, you can use it and create better models. Let us now talk about how to go about using AI to better interpret our models and document it properly as well. Machine learning models provide greater accuracy for credit risks. And because of that, there is this need to be able to use them, but then they are very hard to explain. So, and that creates problems because one, you cannot understand the stability of the model over a longer period of time if you do not fully understand its components. And uh, then there are these requirements for fair lending, uh, which means you need to be able to explain certain components and run certain simulations, which are harder to do if you do not understand what's going in there. And therefore, there is this movement towards explainable AI. And I will talk to you briefly about two such tools which are publicly available as part of Python packages and which help a lot in making sure your machine learning models are meeting regulatory requirements and give you greater confidence on their robustness and stability. So one such tool is SHAP. Again, what SHAP does is takes this machine learning output and uses that to create contributions for uh, income and help you visualize how income is impacting uh, credit risk, or something like age is impacting credit risk, or credit score is impacting credit risk. In this chart, for example, red is a higher value, and you can see for income as well as credit score, the reds are more on the left and the lower values are on the right. So means higher credit risk is associated with lower income or a lower credit score. So even though you started with a black box, creating this sharp feature impact kind of helps you understand and better explain that machine learning model you are deploying. And then there is another tool again available as part of Python packages called Line. And what Line does is it allows you with local simulations. So uh, think of the thought exercise that, okay, if I change the score or credit score of this individual or this applicant I am evaluating by 10 points, and increase it by 10 points, does my credit risk score go down? Is it moving in the right direction? So things like this can be done, and these are very important exercises to help gain greater confidence in the tool we are using. And you know humans love to understand things visually, so these visual representations are very important in gaining confidence of the stakeholders who are all party to the credit risk process. Let me now talk to you a little bit about the importance of documentation. uh, it is obviously very important from a regulatory standpoint, and you have to submit detailed model documentation. But outside that, even if you are not regulated, it is very important for you to have good documentation so that you understand what was done, and when it is time to rebuild or do tests of quality of the model output, you have all that handy. Now, AI can help streamline and automate this process so that detailed reports can be generated without or a lot of human effort, or significantly reducing the human effort. And then uh, you can make sure that comprehensive details and matrices and all the metrics are all captured systematically and nothing is missed out. And what all of this will mean is you will be in much better compliance of regulatory requirements. So let me now illustrate this with a very simple use case. Say you have hired this brilliant kid out of college who knows about modeling, he has learned about the algorithms, but does not have a lot of business context and uh, doesn't have the experience a seasoned modeler or a data scientist would have. In this situation, what you would typically do is have the senior member of your team, or a manager or a senior data scientist, go over the output of this individual and then provide some guidance, mentoring. Now, all of this should be done anyway, but people are busy in timelines, are tight, and things can become a bottleneck. So here is something you can do. uh, in this case, what I did is, it's a very simple exercise, is what we did is we took the statistical output the software generates and fed it to an AI model. And uh, at the top, if you notice the first paragraph, it gives you a lot of explanation about the model. It says it's a logistic regression model. It uses behavior variable. It says the positive coefficients of certain things like credit order count and historical response rate indicate the customer with higher past engagement do a better job. So it is helping the individual who might not know a lot about this business, is fairly new, understand the details and dynamics of the model, and it is helping him interpret the model. And not only that, uh, to the extent it can be a red flag uh, if something is not the right sign. This individual will know by looking at this report. And the next thing it does is, it is looking at all the metrics that were generated, and it is saying that yes, some of these make sense, but you can enhance your work by, uh, for example, generating sharp values. You can uh, do some stress testing by generating some synthetic data, and that will ensure greater fairness compliance, and regulators will like it. So what a senior person would do and help this starting modeler, some that is being done with the help of an AI tutor here. Let us now talk about how AI can help with ongoing monitoring. Let me now talk to you a little bit about what you need to do to check the performance of a model once it has been implemented. So, uh, one of the things you do is performance tracking. When you have developed the model, you have looked at mm, metrics like AUC, KS, Gini, uh, and you continue to keep looking at them periodically. uh, ensure the model's accuracy remains stable, because uh, in periods as results come in, these metrics, if they are falling, that means the model has stopped performing. And so your system can be set up to send alerts when AUC drops below a certain threshold, for example. So things like this can be done. But this is just performance tracking. Another important concept is the drift in data. So the drift in data means that the underlying distribution of your data has changed. For example, your credit profile has changed, or if it's a business to business, the typical type of businesses you are lending to has changed, and some things might creep in without you understanding. Things are different, uh, and you have to check for data drift, because the model assumed a certain distribution, and if the data has drifted too far apart, the model will not do as well. So there are population stability indices, and other techniques to do all of this. And then there are uh, predictive alerts for forecast if the model is going to degrade. And uh, this is a combination of the different things we have seen. For example, if your credit score patterns have changed and you are going for a riskier profile, and your model did not have that risky profile when it was built, the model's performance might degrade. And there might be other things, their economic situation changes, things like that. So there has to be the predictive component there as well to help with the model monitoring. Continuing our discussion on documentation, I want to briefly talk to you about AI's role in model governance. Is basically two broad areas: explaining the model as well as reporting the model. And in explaining the model and also monitoring for bias, we talked about certain tools that are available which can help gain greater transparency into model decisions, especially if you're using some kind of black box model. And then we talked about how bias checks can ensure fairness across different minority groups. You might do these checks by generating synthetic data if enough data is not available, or if enough data is available, you check for these groups to make sure that they are not discriminated against. And uh, so an example would be, SHAP we talked about earlier, a tool that we can use to help with both model transparency as well as with bias checks. And then there is the reporting component to this. There is a lot of automation and systematic documentation available, and which can be done to make the model governance system a lot easier to manage. And when we were talking about interpreting the model, I showed you a simple use case of how you can use that to help us starting data scientists. But similar things can be done to get you started on regulatory documentation, where the grind work of putting everything together is done by AI systems, and the expert human is essentially reviewing. And a good thing about this is doing this systematically creates audit trails which lead to better compliance and accountability. And all this could, be a physical report, or it could, for example, generate monthly performance reports which are fed into dashboards. And so this is a way in which we can systematically use AI for different components of models reporting, as well as to explain the models and be compliant with the different regulatory requirements. Let us now briefly talk about collections optimization. Let me now talk to you a little bit about how you can use automation, machine learning, and AI to create an optimized collection system. The first step would be to set up a machine learning driven customer segmentation system. This will allow you to identify and separate out different risk profiles, different behavioral patterns, and better strategize on how to uh, collect from them. And then within each of these segments, you want to be able to prioritize who to contact, so you would have a machine learning based rank ordering model. Now, once you have done this, then you move to the operational part, because now you have a set of prioritized lists for each of the segments. So then you can have AI driven contact timing, the best time to reach these individuals. You can have a better personalized message, what would be the most effective channel to reach out to them, and what should be the message like, what should the message sequence like. And in doing all of this, if you have created the right automation, you are uh, creating the audit trails and monitoring the conversations and analyzing them to make sure you are learning from them, but also you are not in violation of any regulatory requirements, and your compliance is going well. And apart from these, there are always efficiency you can achieve using AI bots. Not the focus of our discussion, but in an efficient system, if you're designing it, those would uh, be there as well. Thank you so much for joining us for this presentation today. We will now move on to questions and answers.